Hello and good afternoon, everyone. Today we are in the sixth week of the problem solving session. So, the course name of this course is Symmetry, Stereochemistry and Application, and course instructor is Professor Anshuman Roy Choudhury, and I am Probir Maiti. So, today I am teaching assistant of this course, and I will teach some problems of the earlier classes what you have done. So, now start the classes. So first of all, we know last classes I have discussed about that molecule, and in a molecule how the molecule will be symmetric, asymmetric, or disymmetric, and what are the points to be molecule as a chiral. So the symmetric molecules are generally not chiral, as we tell earlier also. So the symmetric molecule which have the improper axis of symmetry, that is the molecule have any improper axis SN symmetry, so then the molecule will be symmetric and the molecule will be achiral. And when the molecule don't have any improper axis of symmetry, so the molecule will be disymmetric molecule, and disymmetric molecule are chiral generally. And if the molecule have no axis of rotation, then these are called asymmetric molecule, and asymmetric molecules are chiral. So if you see that what are the improper axis of symmetry? Improper axis of symmetry means after a rotation, like this example, after a rotation and reflection you got the same structure, then it will be improper axis of symmetry. And now this today's classes I have solving some problem which related to the symmetry and chirality. So before to remind you again that what are the symmetry element are present in a molecule. So the symmetry element like sigma b, sigma v, sigma h means that when the principal axis are perpendicular to the plane sigma plane, and when the principal axis along this along your the principal uh, when the sigma plane is along your principal axis, then it is sigma v. And next that any symmetry like C2, Cn symmetry, and next and so on. So after that I will like in second class I have discussed about what are the symmetry element present in a molecule. So what will be like that C1 symmetry means that is the after 360-degree rotation it will give the same molecule. So that will be C1, and C1 molecule are in a molecule, all molecule are C1 and they are generic chiral molecule. General chiral molecule. And in a molecule, if there will be only sigma planar present in that molecule, so that will be that symmetry will be a symmetry element of their molecule will be CS, and if there will be only inversion center are present, that will be CI. And like for the tetrahedral molecule, that is the four group are placed, octahedral, total 3 6 group are placed, icosahedral, and so on. So in that, so I have told about that in a molecule. So these chart are mm, really helpful to understand that what are the symmetry are present in that molecule. Like in a molecule, if that will be uh, your the principal axis is more than one, more than C2 principal axis are present in a molecule. So that will be your D group element. Like the symmetry will be DNH or DND. DNH will be happened when there will be some sigma H planar passing through each other, and then DND will be when there will be sigma H and sigma B both are present. And if there will be nothing at present, sigma H or sigma B, then that would be DN. In another one cases when the molecule have only one C2 axis, and in between one C2 axis only sigma H plane are present, so then that will be symmetry will be CNH. CNH means what are the principal axis and this number will become as n, and h for that sigma is planar past. If there will be sigma v planar past, then that will be cnv, and there will be any s2n improper axis of rotation, then that will be s2n, and if there will be no sigma v and no sigma h, then that will be cn. So now I give some example of this molecule. So like this molecule have this trans molecule have some C2H symmetry, because the principal axis would be like along the z axis, and our sigma plane will be like that. So if you go, if you give you like, so what will be the principal axis? So this will be x, and this is y, this x direction, this is y direction, and this will be direction of z. So that will be z direction. So the molecule is rotate along the z direction. So by if you consider like a hanging bar, and you rotate some a rope, the hanging bar. So that will be your z axis. So in that z axis, if you rotate this molecule 180-degree, then this molecule give that similar structure as the original one. So this will be C2 axis is present here, and here the only one C2 axis is present. So if there will be only one C2 axis, so it will be C2, and the plane was that sigma plane is passing like this. This one is the sigma plane, so which are not in the plane of the principal axis. So this will be sigma h. So our molecule will be C2H. So these are example of C2H. Now I have seen some example of C2V. So why this molecule is C2V? So there will be also C2 axis is present, because this their water lone pair is present here. So when this C2 axis, like, so we can rotate this molecule like any direction. So if I rotate this molecule like x direction, so this will be replaced by h, this will be replaced by this hydrogen. So this will be C2 axis, and if you cut this molecule like this half, so there will be, so it will contain the principal axis, so this will be sigma v. So this one is sigma v, and also principal axis is passing like that, so this will be sigma v. So the symmetry element of this molecule will be C2. So there will be C2 axis, and the sigma v are present, so there will be C2v. Now the next example one, like this example. So here the number of C2 present is more than one. So if earlier I have told, if there more than one C2 axis are present, like, then, so by this also and this position also, so if there will be more than one C2 axis are present, then that will be your uh, more than one C2 axis are present, then this will be your D configuration will be coming, and it should be that your principal axis is perpendicular to the C2 axis, and if we these are in the all x or y direction, and in your z direction, if you rotate this molecule like 120-degree rotation, 120-degree means, so it will be coming D3. 120-degree rotation, so 120-degree in the z direction, and in your xy direction this molecule have C2, so it will be perpendicular. So our C3 is perpendicular, so our C3 is perpendicular to C2. So now the symmetry element of this molecule will be D3. Now you have to find out what the sigma plane are here. So if you cut this molecule like this direction, so these are all are in the sigma h. So all are there perpendicular, not contain that principal axis, all are perpendicular to the principal axis. So the our molecular symmetry will be D3H. Now the next example one. So next example one. So the C2 is like that. Here also C2. So if there will be more than one C2 are present, so then I tell that will be D symmetry will be coming, so this will be D, and there will be no higher symmetry, so it will be D2. And now that we have to find out what are the planar. If we consider this one as principal axis, so if we cut these molecules, yes, so there will be sigma V is present, and if you cut this molecule like this, sigma H also present. So if there will be sigma V, sigma H all are present, so now we tell this molecule as D2 D symmetry. Now the next example was one where that only nothing sigma B or sigma H are present. So only that D and symmetry is present. So like this example. So after 120-degree rotation, so these are all replaceable after 120-degree rotation. So this will be our D3 symmetry. And now that S2 symmetry, I told that when that in a molecule after rotation and after reflection, it will get that original structure, original molecular configuration, then that will be S2 symmetry. So now we consider some problem here. So now we have to find out for this example. So comment on the symmetry element present in the following molecule and on their optical activity. So first we have to find out that what symmetry element are present in that molecule, and next we have to find out the optical activity of the molecule. So if we find out in this molecule, so what are the symmetry element present? So if any C2 or anything are present, if we rotate this molecule like this direction, so there nothing will be present. No C2 axis because this Cl goes all are down. So no C2 are nothing are present here. So if we also rotate this molecule like this direction, nothing will be present. If we rotate this molecule like Z direction, then nothing we get the original structure. So no C2 symmetry are present. Yeah. But if we saw this molecule, so there will be some sigma plane are present like from this direction. So in that molecule, what will be the symmetry? So only sigma plane are present in a molecule, no C symmetry are present. So then the symmetry will be CS. So the symmetry element of this molecule will be CS. Now we have to find out the optical activity of this compound. So optical activity. So if in a molecule that sigma plane is passed to each other, so then this molecule will be not be optically active. So this molecule like a meso compound are not optically active. So the answer of this molecule symmetry element present is CS, and the optical activity. So this molecule are optically not active. So answer would be optically not active and CS symmetry present. Now the next example one. So in this example also we have to find out that what are the symmetry element are present in that molecule. So if we rotate this molecule like this direction 180-degree rotation, so what will happen? So if I showing that rotation, so if I rotate this molecule 180 degrees, so what will happen? So if I draw this structure again like this, and now I have rotated this molecule like 180 degree. So originally this Cl all are same. This hydrogen is above, this H is below, so this Cl is below. So like after 180 degree rotation, we get that same molecule. So if that will happen after 180-degree rotation, if you give this same molecule, so this molecule have some C2 symmetry are present in that molecule. But there will be multiple C2 or not. So now we have to find out there will be multiple C2 or not. If we rotate this molecule like this direction, so what will happen? So this H and Cl are goes down and this Cl and H will be above. So this will be not the exact structure. So only one C2 are present. So if this in that molecule only one C2 are present, so the symmetry element of this molecule will be start with C2. Now we have to find out there will be any sigma plane present in that molecule or not. So now we have to find out any sigma plane are present. So only one. If you consider if we cut this molecule like this direction, so CLH all are cut, but there will be some this part are extra. So no sigma plane are passed. And now if you cut this molecule like this direction, so nothing this sub and this sub are not exactly same. So nothing sigma plane are present in that molecule. So only this molecule have C2 symmetry. And now we have to find out that optical rotation. So if there molecule and nothing is present and there will be four different group are attached in that molecule, then this molecule will be optically active. So the symmetry element of this molecule will be C2 and the molecule will be optically active. So I have optically active I've given like OA and optically inactive I given like OI. So optically inactive, so this is optically inactive. Now the next example one. So similarly in that molecule we have to find out what symmetry element are present in that molecule. So if you rotate this molecule, there will be nothing is present. All are different group are attached to that molecule. So like there will be only one symmetry is present, like C1 symmetry, because any C2, C3, nothing symmetry are present in that molecule. After 360-degree rotation, if you rotate this molecule whole, like 360-degree rotation, so 360-degree rotation means so we have in that molecule only C1 symmetry is present. So this molecule are identical molecule. So identical molecule also represent like symmetry element represent like E. So the symmetry element of this molecule are E. And now we have to find out that optically active or optically inactive. So this molecule must be optically active. Now the next example one is the similar to that this example. So in that here will also be no C1, no C2, C3 symmetry are present. Only one symmetry are present because every molecule have this C1 symmetry. So 360-degree rotation, and this molecular is chiral. So 360-degree rotation we get that exact structure. So C1 means that the molecule symmetry element will be E, identical, and what are the status of the optical activity, and the molecule will be optically active. Now we have to find out if the case when the two C2 Cl are above. So what are the symmetry elements are present in that molecule? So if we find this molecule, if there any C2, C3 axis are present in that molecule or not. So if you rotate this molecule like this direction, so nothing will be present. X or Y direction from this direction also nothing will be present here. But if we rotate this molecule by this direction, So there will be some C2 axis is present. If we rotate this molecule by this direction, so 180-degree rotation, so this will be replaced by this, and this hydrogen also replaced by this hydrogen, and above chlorine also replaced by this chlorine one. So this molecule have some C2 symmetry, and only one C2 is present. C2 because that is after 180-degree rotation along the Z. So this molecule is rotate 180-degree which direction along the Z axis. So this molecule has C2 symmetry. Now we have to find out that this molecule have any sigma plane or not. So if you cut this molecule like this have, so it will be exactly cut. So this will be sigma V. So the molecule have C2 symmetry and sigma V, and sigma H will cut this like this direction. So nothing will be cutting because this. So this Cl are similar have. So the molecule have. So if we cut that molecule like this direction also, that will be contain our principal axis direction along the principal axis, all are in the sigma V. So the molecule have sigma V. So the symmetry element of this molecule, the answer will be C2V. Now we have to find out the optical activity. So if we cut, so the optical active molecules are not in molecule, there will be nothing sigma B are present. So if you cut this molecule like this up, so these are similar half to like that one. So there will be some mesoplane. So in a molecule, some mesoplane are passing. So then this molecule are not optically active. So the answer will be optically inactive, and the symmetry element present is C2B. Now the next example one. So in that molecule, so if we rotate this molecule, like earlier, if we want to rotate that molecule 180-degree from the Z direction, so what will happen? So this H will be replaced by Cl, and this Cl is replaced by H. So that these are not exact same. So, but if I rotate this molecule from this side, from this side, so what will happen? So if you rotate this molecule 180-degree from this side, so then this hydrogen is going above and this chlorine is going below, and this chlorine exactly position here in that chlorine. So in that molecule C2 axis are present. Now we have to find out that sigma plane. So the sigma plane, what is the sigma V or sigma H or anything. So if we cut this molecule only, if we cut this molecule like this direction, and nothing another direction are possible, and our principal axis is like this. So it will be perpendicular to the principal axis. So if this is perpendicular to the principal axis, so this will be our sigma H. So in that molecule 180-degree rotation, so the comparison will be C2, and this molecule have sigma H, so that symmetry element will be C2H. Now we have to find out that optical activity of this compound. So if you see this molecule, so in that molecule, so nothing sigma plane is passing from this direction. So only sigma plane has passed through the molecule. If the cases like that, so if the sigma plane only passing through the molecule, so then this molecule will be optically active. So the answer will be optically active, and the symmetry element of this molecule will be C2H. Now the next example one. So here also we have to find out the symmetry element present in that molecule in the following molecules and on their optical activity. So if I rotate this molecule 180 degree from this direction, so this CH3 is replaced by this. So in that molecule C2 is present. So if I rotate this molecule like this direction, so this CH3 will be this side, so nothing will be present. And now we have to cut this molecule, and if I cut this molecule like this direction, so there will be sigma present, and now the sigma is sigma b or sigma is so sigma b because it is contain the principal axis. Sigma b means which contain the principal axis. So sigma b is which along the principal axis, and sigma h is which one is the perpendicular to the principal axis. And sigma h will be perpendicular to the. So the symmetry element of this molecule will be C2b. Now we have to find out the molecular it's optically active or optically inactive. So in that molecule, that sigma plane are passing. So this is an example like a mesomolecule one. So the optical activity of this molecule will be optically inactive. Now the next example one. So there will be nothing C2 or anything present in that molecule because one CH3 is above and one CH3 is down. So like in these cases, so if I draw that chair or board form of this molecule, so this will be like this CH3, like that. There will be one CH3. So the molecule have no C symmetry. So and also there will be nothing sigma plane is passing to each other. So this molecule like only C1 symmetry is present. So this molecule an example of E, and also the E molecule are generally optically active. So the rotation of this molecule is optically active because optically active molecules are those which are rotate the plane fluorescent light in a one direction. So this will be optically active. So if you consider that example of this symmetry element optically activity again, so first of all we have to find out in that example, so what are the symmetry element in that molecule. So first we have to find out that after which rotation the molecule give that give that the exact structure. So first of all, we have to find out in that molecule any C to C symmetry are present in that molecule or not. So after finding out that any C symmetry, now we have to first we have to find out any C symmetry present in that molecule or not. Second, we have to find out that any sigma plane is present in that molecule or not, and if the sigma plane is present, so then mm, what sigma is present, is sigma v or sigma h. So how we will know sigma v or sigma h? If our principal axis is contain the sigma plane, then that will be sigma b, and if it is the perpendicular to the principal axis, so that will be sigma h. So then we have to give that symmetry element representation. So like this example, so there will be only sigma plane is passing, no C symmetry is present there, so the symmetry element will be CS, like this. Now we have to find out the optical activity. So from optical activity we know that in that molecule we have to four different substituents present in a molecule, and the molecule should not any sigma plane passing through that molecule. So then that molecule will be optically active. But in that molecule, there will be some sigma plane pass through that pass in between that molecules, and then that will be optically inactive. So symmetry element will be Ca, Cs, and optically inactive. Now similar example, we have to find out that what symmetry element present in that molecule and what sigma plane are passing. So there will be no sigma plane are passing, and only C2 symmetry is present. So that symmetry will be C2, and the molecule will be optically active. In the next example one, so only in that example, so there will be nothing is present, and also the four substituents are different. So this molecular, this center is chiral, also this center is chiral, and the molecule have nothing, no symmetry element present, no C symmetry are present. So only C1 is present in every molecule. So then the molecular identical. So identical are molecule are generally the optically active. So in a molecule, if you find out nothing sigma or nothing C are present in that molecule, so then this molecule must be optically active. So in a molecule, if you find out any S symmetry are present, so in that molecule, if you consider any S symmetry are present or not, if you rotate this molecule 180 degrees, then what will happen? So this will be the cases. 180-degree rotation. So our hydrogen will be above. Air will be below. Then the reflection. If we pass a mirror plane, then what will happen? So our edge will be above, CL will be below. So nothing is symmetry present in the molecule. So in a molecule, any asymmetry present, also then the cases the molecule will be optically inactive. But if there will be nothing asymmetry are present or nothing sigma plane are present in the molecule, then that will be optically active. Similarly, this example as that earlier one. So this molecule have no sigma plane, nothing C2, C3 symmetry are present in that molecule. Also, no asymmetry present in that molecule. So now find out that asymmetry present in the molecule or not. So if you rotate this molecule 180 degrees, so Br will be above. hydrogen will be below. Yes. H will be above, L will be below. Now I have to reflect this molecule. So after reflection, what will happen? So H and Cl. So this Cl should be above in that case. So there will be nothing asymmetry. So improper axes are not present in that molecule. So that molecule also optically active. So this molecular asymmetric or disymmetric or symmetric. So S are not present. So that molecule are not symmetric, and there will be no C2 or so the from the asymmetry or dissymmetry, so the molecule should be asymmetric molecule. Now the next example one. So here the cases that we have to find out that any C2 symmetry present in that molecule. So only one C2 is present in that molecule. So C2 are present in that molecule. So if we rotate this molecule like from the Z direction, one C2 is present and our sigma plane is passing through each other. So C2V. So C2P is present and sigma V is present. So the configuration will be C2V and the molecule will be optically inactive. Earlier I also tell that when in that molecule, so the 180-degree rotation from this direction and sigma plane is this. So sigma is present and one C2 is present. So this will be C2H symmetry and the molecule will be optically active. Now this molecule will have some C2 axis and the sigma plane, and sigma plane was sigma V because I cut this molecule like this direction. So C2 and sigma V, and the optical active, it will be optically inactive because that sigma plane passing through the bond. And for this example, no sigma plane are passed and nothing C2 C3 symmetry present. So this molecule like we have as an identical molecule E, and identical molecule are optically active. So now we have to some example about the UPAC name of the compound. So that given that example one, so now we have to first find out that numbering. We have to given the numbering for UPAC name. We have already said that we have to give the numbering one. So and the numbering one will be started that the functional group will be placed in that position where will be uh, where the minimum number will be given in the functional group. So if we started numbering from this direction, the functional group will be here. So first 1, 2, 3. At third position there will be functional group, fourth, fifth. This will be max. There will be this direction will be maximum one. So you have to give a numbering from this. So there will be one methyl group is here. This will be 2. This will be 3. And this will be 4. This will be 5. And this will be 6. So total 6. 6 means X. Now we have to find out what are substituent. So in the 3 and 4, there will be methyl group. So 3, 4 dimethyl. and that 6 are present, that is X, and in that 3 position there will be one N. So 3,4 dimethyl hexene or hex 3N, and at 2 position there will be Y. The main functional group will be OH, so 2Y. And now we have to find out this molecular Z or E. So if the highest priority are in the same direction, then that will be Z, and if highest priority are that different direction, then that will be E. So in between this molecule, this have the second highest priority. Here also these are the second highest priority in between these two. So the molecular configuration will be Z. So the UPAC name of this molecule is Z34 dimethyl hex 3N2-ol. Now we have to, if this molecule are given in a like this, whether some bond are above and some bond are below. So here the methyl OH are above the plane, and this side these are in the below the plane. So now this center is a chiral center, and every chiral center have some nomenclature like R or S. So this will be our chiral center, and here the chiral center are defined where the bond are, how the bond are placed. So the chiral center some configuration like R or S configuration. So the name in the UPAC name we have to give in the R or S. So how to find out R or S? So for finding out R or S, so we have to find out what four substituent attached in the chiral center. So this for OH, methyl, hydrogen, and this side. So this will be our highest priority, and this N side will be our second highest priority, and this will be third highest priority. And the direction of rotation is 1, 2, 3, that is anti-clockwise. So anti-clockwise direction, or for priority will be above. So then the configuration will be S. So the molecular name will be, UPAC name will be S. Sorry. So if the direction is anti-clockwise and our priority will be below, then the configuration will be R configuration. So our molecular name will be R, Z, and now the similar thing, 3,4 dimethyl. So R and Z will be in bracket, and next name will be 3,4 dimethyl X3 and 12. So if any molecule, if we find out any R or S configuration are present in that molecule, then we have to start the name like defining this chiral center, then the rest of the molecular name. Similar the next example one. So we have to find out in that molecule. So this will be our chiral center. So in that chiral center, so we have to find out that chiral center is R or S or no. So these are the chiral center defining. So this chlorine will be first highest priority, which will be second highest priority, and this third highest priority, and this will be our fourth highest priority. And our direction of rotation is one, two, three. So, direction of rotation is 1, 2, 3. So and our for priority will be above the plane. So then the comparison will be R. So this will be mistake. So this will be R. And now we have to find out this molecule is E or Z comparison. So the highest priority in between this. So this one highest priority, this one the second highest priority, and priority in between this. So this one is the second highest priority and this one is the first. So the second highest priority are opposite to each other. So the molecular comparison will be E, and numbering of this molecule, this will be 1, this will be 2, 3, 2, 3 and 4. And at third position there will be some 3 ethyl group are present. So the molecular name will be 2-chloro 3-ethyl pent at 3 position 1 double bond. So there should be N, and the main functional group will be OH. So the name of the molecule will be R, and E will be in bracket 2-chloro 3-ethyl pent 3 and 1. So if I repeat all the things again. So in this today's classes, we have to tell about that symmetry element, and we have to find out the optical activity. And optical activity in a molecule, some improper axis is present in that molecule, then that will be symmetric molecule. Symmetric molecular will be optically inactive. And if in a molecule, the molecule will be disymmetric or asymmetric, then that will be optically active. So these are the optically active one. And in that optically active molecule, if some C symmetry are present, then this molecule will be asymmetric. Any C symmetry is present, then that will be disymmetric. And no C symmetry are present, then that will be asymmetric one. And I have given some example of that improper axis of rotation. So improper axis of rotation is that after rotation and reflection, if you get the same molecule. And some sigma b and sigma h. What is the sigma b? Sigma b means where the principal axis and sigma plane are in the same same plane. Or if the sigma plane and principal axis are in the perpendicular, then will be sigma h, and some C2 symmetry. And here the main chart where how the molecule will be sigma b, sigma h, or D symmetry. Like that, the identical chiral molecule are generally E symmetry. E symmetry means so the identical molecule. So any molecule after 360 rotation, it always gives the same structure. And every molecule have some C1 symmetry must be present in the molecule. And if you find out there will be more than one C2 is present in the molecule, and your principal axis is perpendicular to a C2 axis, then the D in the symmetry element D group will be coming. And if there will be only one single C2 is present in that molecule, then there only that group name of the symmetry group element will be C or S. So now I give some example one. Now you have to find out in that molecule that this molecule are optically active or not. So optically active molecules will be that there where the four different in a chiral center, four different center will be present, and also there will be nothing sigma plane is passing through the bond. So if this will be cases the sigma plane passing through the bond, then that will be optically inactive. Like this example, this molecule are optically inactive, and that there will be nothing sigma only sigma plane is passed, but nothing C2, C3 symmetry is present in the molecule, so this symmetry element will be CS and the overall molecule will be optically inactive. Next example one. So we have to find out NC symmetry present. So we have to rotate this molecule 180 degree. So this will be exactly same. Same to this molecule. So in that molecule C2 symmetry is present, but there will be nothing sigma are present because you cut through this side or this side, so there will be not the similar half. So this will be C2 symmetry and that molecule will be optically active. And also this all are in the chiral center, and after C2 symmetry or any, so there will be no C2, no D symmetry and no S symmetry are present. So the molecule will be optically active, and this molecular symmetric or asymmetry. So this molecule will be asymmetry one. Similarly, this molecule also asymmetric and optically active. The C2 is present along the Z axis and sigma plane in the chlorine if the chlorine bond are cut and hydrogen are cut, so sigma plane. So the C2b is present and this molecule will be optically inactive. But the next example one similar like on this Cl and Cl are below. So now the C2 plane will be like this and now the sigma plane will be like this. So there will be sigma H present, so the symmetry element will be C2H, and also this molecule have optically activity. In this example one, so C2 is like this 180 deviation will give the same molecule and sigma plane also. So the symmetry element will be C2B and this molecule are optically inactive. Next example one, so these are similar to the identical molecule and identical molecule are generally optically active. And find out the UPAC name. So UPAC name we have to earlier cases we have to find the functional group and naming there. Here the special cases there's some one chiral center is present. So if the chiral center is present, so we have to find out the RS nomenclature of the chiral center. Then we have to find out. So first we have to find out the RS nomenclature. Then we have to find out the what functional group are present in the molecule. Then we have to give the numbering of that molecule. And then the next will be overall name of the molecule. So here will be some 3 and 4 position methyl group is attached, and this will be the longer chain. So this side will be the longer chain, and so the numbering will be start from this side 1 2 3. So and 3 4 dimethyl xn x3n, because in 3 positions some double bond is there, 3n, and at 2 positions some all. So 3 4 dimethyl hexane 3 and 2 all, and overall functional group is due to this OH molecule. So the next example one, the molecule also R. Between R and S, this molecule is R. And now we have to find out that this configuration are E or Z. So the Z configuration will be like this in a double bond. If the all priority are in the same direction like this, So this comparison will be like Z comparison. And if similar things, this hydrogen is above, and this methyl, so this will be your P comparison. So here E and Z, so this will be our first priority, this will be second priority, and here it will be first priority, and the above one will be second priority. So that two priority are opposite to each other, then that will be E is coming. This convention E, and in between cis and trans, so this will be our, so Z are cis configuration and E are trans. So if the similar problem is coming, so you have to find out that RS nomenclature of any molecule. Like if I given some example of this molecule one, so how we have to find out that RS nomenclature of that molecule. So in that molecule, some it's like chlorine is above, and this one example like hydrogen. There will be hydrogen. So this one the above group. So above there will be some chlorine. So this molecular chiral or not. So this molecular not chiral because there will be two methyl are present in the same site. Same site and two methyl are there will be no four substituent present in the same molecule. So this should be something different. So this will be OH. So now this molecular chiral. So in a chiral center now we have to find out the four substituent present. They are find out the priority of this molecule. So this fluorine will be first priority. This one will be second highest priority, and this one will be third highest priority. And if we find out that 1, 2, 3, this one is clockwise. So direction of rotation is clockwise, and our fourth priority, this one fourth priority, is below the plane. So then the configuration will be R. And similar things if we give like this molecule one, as the fluorine is below and hydrogen will be above. F4 parity is below. This one will be 4 parity. So this will be OH. First, this one will be second, and this one will be third. Now 4 parity is above. So this the comparison of that molecule will be S. And is they are the like the mirror image to each other. So if you like this, the mirror image relationship between, then the molecule should be mirror image molecule. The RS one should be R and one should be S, and that molecule will be enantiomer. The relationship between that molecule will be enantiomer. Enantiomer means there will be some mirror image relationship between that two molecules. The diastereomer means there will be nothing relationship between the molecule. Nothing mirror image relationship, not the same molecule. So then that will be diastereomer. And homer will be if the after rotation, yeah, after C2 rotation or any rotation, if we give the same molecule one, then that will be your homomer. Like this you have to find out. Similar thing if we for in a plane like this, if a molecule are given. So and we have to find out that RS nomenclature of this molecule. Like here will be some Cl is present, here some hydrogen and OH, here is some methyl. So first, second, and this will be a third priority. So first, second, third. The direction of rotation is clockwise, and our fourth priority is vertical, and the configuration will be R. And if the similar cases are for priority in the horizontal plane, like this, I only replace this H and OH. Now we have to find out the configuration of this molecule. So this will be first priority, this one will be second highest priority, and this one will be third highest priority. So first, second, third, the direction of rotation is clockwise. But now our fourth priority in the horizontal. So the configuration will be yes. So for every cases, so like in a Newman projection or any Dodge projection, that the clockwise will be R, anti-clockwise will be S. But in a in a Newman projection like this, example one, so if that highest priority will be in that vertical, the lowest priority will be in the vertical, then clockwise will be R, anti-clockwise will be S, and if the lowest priority, that is the fourth priority one in the horizontal in the plane, then that configuration will be that clockwise rotation will be S configuration and anti-clockwise will be R configuration. If we given some example like this, some chlorine, how we will draw this molecule in Newman projection. So if you draw this molecule I have told earlier, so there will be draw like this first. Now we have to find out that RS nomenclature of this R or S. So this one will be highest priority, this one the second highest priority, and this one will be third highest priority. So first, second, third. So the direction of rotation is anti-clockwise, and anti-clockwise direction of rotation, and R4 priority is below, so the configuration will be S configuration. Now we have to place this molecule. So how we place? So this will be F, some H, and I always tell that when the Cl is above, so now I place this in Cl. Now we have to find out if I draw these things are right or wrong. So here it will be highest priority, this will be second highest priority, and this will be third. So now the direction of rotation is 1, 2, 3, and 4 priority is in the horizontal. So it will be yes. So I have drawn these things is right. Now for these things, so this will be RF, this will be BR, and this should be OH. So this point here will be, this one is the highest, this one the second highest priority, this one third highest priority, and this will be the fourth priority in the vertical plane, and 1, 2, 3, 1, 2, 3 direction of rotation. So this also yes. So now you have to find out this one is yes or not. So this one is the highest, so this BR will be highest priority, this one will be second highest priority, and this will be below the plane. This one will be third highest priority. So one, something like hydrogen atom. So if this will be hydrogen, so then the priority will be 1, 2, 3. Yes, and here, so 1, 2, and 3. Clockwise, So here the bromine should be placed here. So this I have draw wrong. So this will be bromine will be here, and this H will be here. Now this one is right.